Okay, in this last section, 5.3, we're going to use our trig ratios to solve real world problems using angles of elevation and depression. So we're going to start with angle of elevation. It is the angle between an observer's line of sight and a horizontal line. So this would represent your angle of elevation. Okay, now, with your word problems, you need to make a sketch or make a drawing and label what you're given and what you're looking for, because you're going to use this information to determine the appropriate trig ratio. And I'm going to introduce a new variable with these word problems, and it is the Greek symbol theta. Think of theta like x was with your algebra. Theta is used to designate angles in trig. All right, so let's start with example 1. Angle of elevation from a rock on the ground to the top of a building is 52 degrees. The rock is 125 from the base of the building. How tall is the building? So again, we start with a sketch. Here's the building. Here's the rock. Here is the angle of elevation from the rock to the top of the building. So there's our sketch. Now we're going to put in information. We're going to label it. Angle of elevation, 52 degrees. So I'm going to mark that here. The rock is 125 feet from the base of the building. So this is 125 feet. And we want to know how tall is the building. So we are looking for H. Now, I'm going to highlight the hypotenuse. There's a couple of assumptions. We are assuming the building is perpendicular to the ground. Therefore, we have a right triangle. We're looking for, since we don't have the hypotenuse, we know we're going to be using tangent. So I'm going to go ahead and write tangent 52. And tangent is opposite over adjacent. So it's going to be H over 125. To solve for H, we multiply both sides by 125, and we get H equals 125 times tangent of 52. Plug that in your calculator, and you get 159.9. So if we were rounding this to the nearest foot, the building is 160 feet tall. Example 2, we have a 14-foot ladder used to scale a 13-foot wall. At what angle of elevation must the ladder be situated in order to reach the top of the wall? So again, we're going to start with a sketch. Here's the ground. Here's the wall. And we're going to prop a ladder so it reaches the top of the wall. Again, we're going to assume this wall is perpendicular to the ground. We are looking for the angle of elevation. This is the angle of elevation. We don't know what it is, so I'm labeling it theta. Here's our hypotenuse, which happens to be the ladder. And the ladder is 14 feet long, and the wall is 13 feet high. Okay? Since we have information about the hypotenuse, again, sine or cosine. We know the length of the opposite side, so that means we're going to use sine. Our setup, sine of theta equals the opposite, 13, over the hypotenuse. So as in our previous lesson, to find theta, we're going to use the inverse sign. So we have theta equals inverse sine of 13 divided by 14, and we get 68.2. We've been rounding our angles to the nearest degree, so if we round this to the nearest degree, we have 68 degrees. Example 3. It's a little more complicated, but still doable. Brian's kite is flying above a field at the end of a 65-meter length of string. Angle of elevation to the kite measures 70 degrees. Brian is holding the kite 1.2 meters off the ground. How high above the ground is the kite flying? So here's the ground. Here's Brian. He's holding the string of the kite. And so we can create a right triangle. So now we're going to fill in our information. The kite is at the end of a 65-meter length of string. Here is the string, which happens to be our hypotenuse. It is 65 meters. The angle of elevation to the kite measures 70 degrees. So this is 70 degrees. And Brian is holding the kite 1.2 meters off the ground. So from here to here is 1.2 meters. Now we're going to use trig to find this value here. And then to find out how high above the ground, we're going to need to add this to the 1.2 meters. Okay? So we have the hypotenuse, sine or cosine. We're looking for the opposite side, so we're going to use sine. Sine of 70 equals h over 65. That means h is equal to 65 times the sine of 70, which gives us 61.0 meters. So the total height of the kite is going to be those 61 meters plus the 1.2 meters that Brian's already holding it above the ground, meaning the kite is 62.2 meters above the ground.